Hi everyone, I'm Shubham Jawar. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2021, Paper 1, Mathematics, and the question for this video is this. Let there be function f defined from all real to all real, that means domain being all real values and codomain being all real values, be defined by fx is equal to x square minus 3x minus 6 divided by x square plus 2x plus 4. Then which of the following statements is or are true? There are 4 statements, so we need to comment upon increasing, decreasing in different intervals respectively, whether f is onto or not, and range of f. It is a multiple choice, multiple correct type question. Here, as you see f of x, the denominator is not becoming 0 for any value of x. In fact, you would not allow it to become 0, but it is not even tending to 0 for any value of x. Why? Because here this is a quadratic with discriminant negative. So you may write f of x as x square minus 3x minus 6 divided by x plus 1 whole square plus 3. So there is no value of x for which fx will tend to infinity or minus infinity. So that means it is definitely not onto. Now to comment upon f being decreasing or increasing respective intervals, let's differentiate. So f prime x is equal to, using quotient rule, it turns out to be this. On further simplification, we get this. And denominator never becomes 0. In fact, it is always positive. And what about numerator? If you take 5x common, it becomes 5x times x plus 4. So that means f prime x, if you go by wavy curve method of understanding, f prime x is increasing for x greater than 0. It's decreasing between minus 4 to 0, and it's increasing for x less than minus 4. F prime x is positive for x greater than 0 and for x less than minus 4, and is negative between minus 4 to 0. So that means fx is appropriately increasing and decreasing in respective intervals. So here f is decreasing in this interval minus 2 open to minus 1 open, absolutely. F is increasing in the interval 1 open to 2 open, absolutely. F is not onto, that's what we had already discussed. Range of f in this interval minus 3 by 2 close range of f is minus 3 by 2 close to 2 close. Let's check. So first it is increasing. So try to understand that as you plot the graph, so there is no discontinuity anywhere. It is defined for all values of x. Why? Because denominator is not becoming 0 for any x. So here as x tends to minus infinity, fx tends to 1. However, it tends to 1 from above. How can we say that? As x tends to minus infinity, x square from numerator denominator, they like kind of tie, kind of. And minus 3x, as x tends to minus infinity, will be something positive, and 2x will be something negative. So that means numerator will be a bit more than denominator. Of course, the dominating terms would be the x square in numerator and denominator. So here it's just about whether it will tend to 1 plus, that means little more than 1 or little less than 1. So it tends to little more than 1 when x is tending to minus infinity. And numerator would have 2 roots, one negative and one positive. So clearly, it will somewhere move like this. And from 0 onward, it is increasing. So here it increases like this, and it will go something like this. Now at infinity it tends to 1 from below, which you can understand from here also. It will not go above and then come down. Why? Because it is increasing for x greater than 0 consistently. So that clearly means that the range of f would essentially be the minimum values f of 0 and the maximum values f of minus 4. Why? Because this here derivative is becoming 0 at x equal to minus 4, and here derivative is becoming 0 at x equal to 0. So f of 0 essentially is, as you put x to be 0, don't put here f of x value is what we are looking for. So minus 6 by 4, it essentially becomes minus 3 by 2. And when you put x to be minus 4, f of minus 4 turns out to be 11 by 6. You can put x to be minus 4 in this expression. So that means our range is minus 3 by 2 close to 11 by 6 closed, and not minus 3 by 2 close to 2 closed. So D is also not correct. So E and B are the answers. Thanks for listening. Stay tuned for the next question.